Hi Senior 1, welcome to my video. I am Ms. Ghadir Tariq. Today I am going to talk about how to find and solve the questions on Egyptian Knowledge Bank. Study now. Please select a subject, chemistry. Secondary one, Britannica. I will start with Hess law of heat submission, curriculum topic. Okay, Hess law of heat submission. I will choose Hess law of heat submission, revision activities, launch. Hess law of heat submission, revision activities. Let's start. We will solve 2 questions. There are 12 marks available in this quiz. Start. Fill in the blanks to complete the following sentence. The first law of thermodynamics states that the energy of a system is constant in an isolated system. Energy cannot be destroyed or created, but it can be transferred or changed. According to Hess law, the enthalpy change of a given reaction is the same irrespective of the number of steps in the process. Okay, next question. Indicate whether each statement is true or false. Hess law applies only to exothermic reaction. False. Hess law can be used to calculate the enthalpy change for the reactions that are difficult to carry out. True. Hess law applies only to the reactions that cannot be carried out safely in one step. False. Hess law is an application of the first law of thermodynamics. True. Hess law applies to all chemical reactions. True. Hess law follows directly from the law of conservation of mass. False. To apply Hess law, you can manipulate equations by multiplying or reversing them. True. Finish. Okay, you achieved 12 out of 12 marks. There are 5 marks available in this quiz. Start. Heat is conserved in a closed system. First law of thermodynamics. The energy released by a reaction to the environment is equal to the energy lost from the reactant as they form the product. So this is the law of conservation of energy and the first law of thermodynamics. Next question. The change in energy in a 2-step reaction is the same if the reaction occurs in 3 steps for the same reactant and the product. Hess law. The energy change in any reaction is the same irrespective of the number of steps in the reaction. Hess law. Which law can be used to describe or analyze the energy changes that occur when carbon burns into oxygen? First law of thermodynamics and Hess law. Okay, 100%. You achieved 5 out of 5 marks. Now we have finished this question. Now I will solve another type of questions, which is called Hess cycle curriculum topic. Hess cycle revision activities launch. Hess cycle revision activities. Hess cycle summary quiz. There are 10 marks available in this quiz. Start. Decide whether each of the following statement is true or false. Hess law is an application of the law of conservation of mass. False. Hess law is used to directly determine enthalpy changed by the experiment. False. Reaction in Hess cycle diagrams can be reversed. True. Hess cycle can represent only one alternative route for the reaction at a time. False. Next question. Fill in the blanks to complete the following sentence. When an arrow in a Hess cycle diagram is reversed, the sign of the enthalpy change must be reversed. The enthalpy change of a reaction is the same irrespective of the number of steps in the process. Hess cycle diagrams are often used when it is not possible to find the enthalpy change for the one-step reaction by the experiment. Select all that apply to describe reason why it is helpful to use Hess law and Hess cycle diagram. First of all, the target of a reaction is too slow. The target of the reaction is too dangerous. The target of the reaction requires extreme condition. If you have any question, just write them in the comment below and I will be glad to answer them. You achieved 10 out of 10 marks. Let's turn to complete the question. There are 4 marks available in this quiz. Start. What is enthalpy? Which is the best statement of Hess law? The enthalpy change of a reaction is the same no matter how many steps are in the reaction. What is the purpose of a Hess cycle diagram? To represent Hess law as applied to a set of reactions. If a reaction is reversed in a Hess cycle diagram, then the sign of the enthalpy change must be reversed. Check answers. Finish. 100%. Practical task, Hess law of heat summation. Revision activities, launch. Determining enthalpy changes quiz. There are 4 marks available in this quiz. Start. The expression E plus BV define which quantity? Define the enthalpy. Check answers. Next question. For a reaction or system carried out in a calorimeter surrounding under condition of constant temperature, which is true, Q surrounding equal negative delta H system. Check answers. Next question. Hess law is an application of which law? Of the first law of thermodynamics. Check answers. What is meant by heat summation? The addition of the enthalpy changes from two or more reactions. You achieved 4 out of 4 marks. Let's complete. Practical task Hess law of heat summation quiz. There are 7 marks available in this quiz. Starts. Indicate whether each of the following statements is true or false. Enthalpy change can often be determined experimentally by measuring heat change. True. All exothermic reactions have an enthalpy change that it is positive, so it is false. If a thermochemical equation is reversed, the sign of enthalpy term changes. True. When the coefficient of a thermochemical equation are multiplied by a factor, the enthalpy terms stay at the same. False. Heat summation is a useful technique to find the enthalpy of a reaction that it is impractical to study in the laboratory. True. Next question. If the reaction delta H1 equals 33 kJ per mole and the reaction to delta H2 minus 40 kJ per mole can be added to get reaction 3, what is the enthalpy change for the reaction 3? Okay. So I have here the mathematical relation of Hess law is delta H1 plus delta H2. So I will add delta H1 plus delta H2. I will add 33 kJ per mole plus minus 40, 33 minus 40, it will give out minus 7 kJ per mole. So this is the question. If you have any question, just write them in the comment below and I will be glad to answer them. Check answers. If you have any question, just write them in the comment below and I will be glad to answer them. Given the following information, what is the enthalpy change of the third reaction? First reaction 2A plus B, it will give out A to B. Their delta H equal minus 990 kJ per mole. Second reaction QA2 plus B will give out Q plus A to B. Delta H equal minus 1500 kJ per mole. Third reaction 2A plus Q, it will give out QA2. So what is the delta H? Okay, first I will write the two equations. I have the first thermal equation 2A plus B, it will give out A to B, their delta H minus 99 kJ per mole. Given the following information, what is the enthalpy change of the third reaction? The first reaction 2A plus B, A to B, delta H minus 990 kJ per mole, and the second reaction QA2 plus B, Q plus A to B, their delta H minus 1500 kJ per mole. Third reaction 2A plus Q, QA2, what is their delta H? So we have two thermal equations. The first equation 2A plus B, A to B, and it's delta H1 minus 990 kJ per mole. And the second equation QA2 plus B, it will give out Q plus A2B delta H minus 1500 kilojoule per mole, and these two equations are already given. Okay, by subtracting equation 2 from equation 1, I will subtract the reactant with the reactant, and I will subtract the product with the product. Okay, so here is the reactant 2A plus B minus QA minus B, and the product A2B minus Q minus A2B. Okay, so I will cancel two signs with each other. B, this one will be cancelled with minus B. Okay, so I will have, by transferring QA2, this QA2, I will transfer it from the left hand side to the right hand side with opposite sign. Okay, and I will cancel A2B, this one, I will cancel A2B with minus A2B like this. Okay, so 2A equal minus QA2, it will transfer to the right hand side by the opposite sign, so minus QA2, it will be plus QA2, and we have minus Q from the beginning. I will transfer this Q from the right hand side to the left hand side by the opposite sign, so it will be 2A plus Q, it will give out QA2. This final result, it is like this one, 2A plus Q will give out in the product QA2 like this equation. Is it right? So what will happen? I subtract the equation 1 from equation 2. So delta H will be equal delta H1 minus delta H2. Delta H1 minus 990 kilojoule, and delta H2 minus 1500 kilojoule. I will subtract delta H1 minus delta H2. It will give out 510 kilojoule per mole. So this is the answer. Okay, if you have any question, just write them in the comments below, and I will be glad to answer them. Okay, you achieved 7 out of 7 marks. Let's complete our questions. There are 6 marks available in this quiz. Start. When can Hess law be useful applied? The target reaction is too slow. Yes, the target reaction is too dangerous. So this statement is right. The enthalpy change of the step in a reaction are unknown. No. The target reaction is quick and easy to study. No. The target reaction is too complicated to study practically. Okay, this statement is correct. The enthalpy change of the target reaction can be easily studied directly. No. So we have complete the 6th question. Finish.